Hi friends, to another episode on Awesome Maths where I, Souvik, help you with very tricky and exciting maths problems. As discussed before, hope you do like the problems and please subscribe to my content and also share them with your other friends and like my videos as well so that I get motivated to share more such content with you. With that, let us move on. Hi friends, today we will start off with a problem which is about a square which is embedded within a right angle triangle. So we have a triangle ABC which is right angled. So we have a right angle here 90 degrees. Find the area of the square BDEF. So there is a square which is embedded here. We will label its sides x, x, x and x, right? So we have to find the area of the square. Now to answer this question, so area of the square BDEF is very simply x squared, right? Because each side is x. Now we can solve this problem using two ways. One is a bit longer and one will be very short. So the shorter way first. Now this angle is basically, let's just call it theta. Now this angle will also be equal to theta because we have these two lines which are in fact parallel to each other. So as a consequence of that, these two angles will be similar, right? So angle AED is equal to angle ACB is equal to theta, right? Now what is tan of theta? Tan of theta, if we just consider this small triangle CEF, right? Tan of theta is equal to opposite by the adjacent, so that's x by 5. But tan of theta here is equal to 10 by x, right? So this is equal to 10 by x. So if we just solve this, we get very simply x squared is equal to 50, right? So the area which is x squared is equal to 50. This is the simpler approach. Now we will try a more complicated approach which will take some time. Now we don't need this complicated approach, but sometimes in problems like these, things are not so crystal clear and some sides will not be specified. There we may have to use a slightly different approach. I will show you that approach now. Now we know that this triangle is also a 90-degree triangle. So we have got this triangle, we have got this triangle which is the big triangle, we also have this small triangle, right? So let us do something. Let us label these parts. So we will label this AE to be Y, we will label EC to be Z, okay? Now in triangle ABC, right? So this is the first approach which we have done. Now just try using the Pythagoras theorem. So in triangle ABC, what we can say is x plus 5 whole squared plus 10 plus x whole squared is equal to y plus z whole squared, right? This is the Pythagoras theorem. What this implies is x squared plus 20x plus x squared is equal to y squared plus 2yz plus z squared, right? So simplifying this further, this becomes 2x squared plus 30x plus 125 is equal to y squared plus 2yz plus z squared, right? So we will just call this equation 1. Now let us look at the second triangle. So I will move this here. Okay, so triangle ADE. Now what does triangle ADE show, right? So triangle ADE, that shows that, so 10 squared plus x squared will be equal to y square, right? So 10 squared plus x squared is equal to y squared, which means x squared plus 100 is equal to y squared. Clear? Now how about this triangle, triangle EFC? Here we have the right angle here. So here 5 squared plus x squared will be equal to z square, right? So triangle EFC, 5 square plus x square is equal to z square, which means x squared plus 25 is equal to z square, right? Now from these two equations, what this gives us, I will just write it in a small form here. Y is equal to square root of x square plus 100. This will be equation 2. And from here we get z is equal to square root of x squared plus 25. This will be equation 3, right? Now all we have to do is substitute the values of y and z in our original equation 1. So what do we get? Substituting for y and z here, what we get is 2x squared plus 30x plus 125 is equal to, so y squared we already know is x squared plus 100 is equal to x squared plus 100, right, plus 2yz. So y is this, z is this, so plus 2 x squared plus 100 into x squared plus 25 plus z squared is anyway x squared plus 25. Now from here you can see that we can just cut off these x squares here. There are 2x squares here, there is 2x square here, there is 100 plus 125, so that's 125, so we can cut off this, right? So finally what we get is 30x is equal to 2 into x squared plus 100 into x squared plus 25, right? Now we can cut the 30 with the 2 and we will get 15 here. Now we square these sides. So what this implies is 15x whole squared is equal to x squared plus 100 into x squared plus 25. What that gives us is 225x squared is equal to, I will expand this, x to the power of 4 plus 100x squared plus 25x squared, so that's 125x squared plus 2500. This gives us a nice quadratic equation, x to the power of 4 minus 100x squared plus 2500 is equal to 0. Is this clear? 125x squared minus 225x squared, that is minus 100x squared. Now this is simply nothing but x squared minus 50 whole squared is equal to 0. If you just have this simplified, this will give us, what will this give us? X squared minus 50 equals 0, or x squared is equal to 50. So we get the exact same result following this long method as Okay, moving on to a second problem. This will be far easier, but it will appear difficult. The previous one obviously appeared simple, but was actually difficult. So 16 to the power of sine squared theta plus 16 to the power of cos squared theta is equal to 10. Find theta. So while solving this, we will use the fundamental concept of geometry, which is sine squared theta plus cos squared theta is equal to 1. So this is fundamental trigonometry, right? So hence, when we substitute for cos squared theta, this equation becomes 16 to the power of sine squared theta plus 16 to the power of 1 minus sine squared theta is equal to 10. Writing it down further, 16 to the power of sine squared theta plus 16 divided by 16 to the power of sine squared theta is equal to 10. Now very simply, let y is equal to 16 to the power of sine squared theta. Easy. Then we get y plus 16 by y is equal to 10, and hence y squared plus 16 is equal to 10y. Now we will solve this together after this. This means y squared minus 10y plus 16 is equal to 0. I mean, you have done this quadratic equation before, but I will just solve it here, right? Rough work. Y and y, we will put two x's. Now what will give us minus 10? Minus 8 and minus 2. So 16 is equal to minus 8 into minus 2. Minus 8y minus 2y is equal to minus 10y, right? So y minus 2, y minus 8 is equal to 0, which gives us y can be 2 or 8. Now let's split this. We have seen before what is y. Y is 16 to the power of sine squared theta, right? So this is equal to 2, or 16 to the power of sine squared theta is equal to 8. Right? Now very simply, 16 to the power of sine squared theta here basically implies a 16 to the power of 1/4. Right? Because 2 is equal to 16 to the power of 1/4. Let's do something similar here. 16 to the power of sine squared theta. Now what is 8, right? So 8 is basically 2 cube. Now 2, as we know, is 16 to the power of 1/4. So this implies 16 to the power of 1/4 whole to the power of 3 is equal to 16 to the power of 3/4. So from this first one, what we get is sine squared theta is equal to 1/4, which means sine theta is equal to half. We will just take the positive numbers, of course. Okay. So if sine theta is equal to half, we will know that theta is equal to 30 degrees, right? And here we have sine squared theta is equal to 3/4, which implies sine theta is √3/2, which implies theta is equal to 60 degrees. So there are two possible answers for this. Either theta equals to 30 degrees or theta equals to 60 degrees. Both of these will satisfy the problem that 16 to the power of sine squared theta plus 16 to the power of cos squared theta is equal to 10. Simple. We will meet in the next video. Please do subscribe to my channel for more such exciting problems, and do share them with your friends and like and comment as well. Thank you.